Welcome to Real GMAT Problems, episode 43. Doing real GMAT problems is one of the best ways to make sure that your test day goes well. So let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you're welcome to web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's part of the reason I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the problems we're going to talk through today. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be quite similar to the questions that you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to take away from each one. I recommend pausing after I read and trying to solve the problem on your own, or at the very least, visualize how you would solve it if you're on the go. You might not be able to execute all the steps in your head, but just get as far as you can. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. Let's start with a lower difficulty warm-up problem, and then we'll bump up the difficulty a little bit from there. Today, we're going to focus on word problems. It's the most common type of question on the GMAT quant section, so very hopeful that you're going to walk away with some really valuable takeaways today. This is question number 1. The problem says, in a small snack shop, the average, in parentheses, arithmetic mean, revenue was $400 per day over a 10-day period. During this period, if the average daily revenue was $360 for the first 6 days, what was the average daily revenue for the last 4 days? I'll read that again. In a small snack shop, the average revenue was $400 per day over a 10-day period. During this period, if the average daily revenue was $360 for the first 6 days, what was the average daily revenue for the last 4 days? Option A is 420. Option B is 440. Option C is 450. Option D is 460. And option E is 480. Again, recommend pausing and getting as far as you can here. I'm just going to jump into my commentary. Really great warm-up problem here, especially for a word problems workout. It's also a nice follow-up from our previous episode in the series, which was focused on statistics. So we're going to weave some of those themes into the next couple problems as well. If you want to brush up on averages and means and medians, then that previous episode is going to be a really good way to do that. This is also a good warm-up problem because it pushes the value of organization without integrating too many concepts at once. And that concept of organization is going to come up quite a bit as we talk about word problems together. Let's start by emphasizing the basics of good organization, which is, number one, just consistently writing what's given and what's asked. It's such a simple thing. But really, really powerful. So first, we're given an average over a 10-day period. I'd probably just use some half math, half English there and write something like 10-day average equals $400. I've talked a lot about the half math, half English thing in past episodes, but just in case you're just starting out or this is the first time you're touching base here, what I mean by half math, half English is just an intermediate step between reading what the problem says and trying to make an equation or going straight to doing the math. If you are having great results going straight to the math from reading, by all means, keep doing what you're doing. But I've noticed a lot of people really, really struggle with that. And so you'll usually have better success if you're in that situation by inserting that in between step between reading and actually having equations. You have this kind of half math, half English thing where you can just distill what am I being told here. And then once you have everything that you're being told and what the question's asking you, usually it's a little bit easier to start putting together equations. And that's a gap that I see a lot of people have trouble filling. So going to try to help you fill that today. So that's the half math, half English thing. So after that, I'd write the first 6 days. I guess to be totally exact, I'd probably write first 6 days average $360, something like that, or like 6 days average equals $360 again. It's not really fully math, but not really like fully English. Then I'd write what's asked in a similar form, something like average last 4 days question mark, something like that. You can experiment with what works well for you. The point is having the principle of having that intermediate step is really valuable. How you execute on it, I think, is more personal. So you just want to have a repeatable framework for that. Usually consistent results come from a consistent process. And that's partly why I'm going to be making a lot of recommendations about how you can become more consistent with your problem solving process. Just because missing questions people know how to do is like a big score killer on the GMAT quant section. You might have experienced that if you've been studying for a while or if you've reviewed any practice exams. So just trying to help you get ahead of that and build good habits. Again, something we'll circle back to as we go through the other problems as well. So what's interesting here is as we progress through the difficulty spectrum, one of the big themes in word problems is comprehension. A lot of people can execute the math even under time pressure, but where a lot of mistakes get made is before the math even gets set up. And sometimes, even when they're understanding the question, people tend to make mistakes. They could misunderstand what's being asked. They could misunderstand what's being given, or both. And I think that's the issue a lot of us run into when we're trying to go straight to the equation is our brain like short circuits a little bit, and it just kind of deletes like a key little detail because it's trying to like process what you're reading and process what you're creating in mathematical terms at the same time. So segmenting that, reading first, then writing some half math, half English, then going to equations. I think it just frees up bandwidth for each individual step. And I think it allows people to execute a little bit better on each individual step. And that usually leads to a better, faster result. A lot of people resist the advice I'm giving here just because they feel like the time pressure is too significant. We'll talk about that more later, but it's like, would you rather add 20 seconds to your process and be right 98% of the time, or delete 20 seconds from your process and be wrong, like, 60% of the time, which is a lot of times what happens when we rush. So it's just a trade. It's maybe not a perfect strategy, but I think you'll find it extremely useful. Partially because being able to execute the math, but missing the question because you didn't comprehend it properly is a super frustrating situation to get into. I fell into that trap many, many, many times when I was first studying, when I was in the shoes that a lot of you are in right now. And it's just really best, in my experience, if you can build good habits to avoid it ever happening. Hence the great focus on that right now. So we've already got the start of a strong system for avoiding those mistakes with the steps we've taken so far, just writing what's given and asked in some half math, half English format. And let's now get into making some equations. The first equation I'd probably make is sum divided by number of things equals average for the first piece of information. And that's just the standard average formula. Again, more on that last week if you'd like. The overall average for all 10 days was $400 per day. So I would write sum divided by 10 equals 400. And then I would probably label that as like total or all 10 days, something like that, because I could definitely see myself making another one or two average equations, and I don't want to get confused as to what represents what there. I'd also make a similar equation for the next piece of information that I'm given, which says an average of $360 for the next 6 days. First 6 days, excuse me. So for that, I would write sum over 6 equals 360. And then I would make a label such as first 6 days. I'd probably also make an equation for the question. I talked about this a little bit in last week's episode, so if you want more thoughts on this, please check that out. But the short version is that I personally find it easier to connect the given information with the question if I can make equations for both. I can't always make equations, so obviously there are some other approaches in those situations and some limits to this approach. So you don't have to do this for every single question to have success, but it can be super, super helpful. And I think you'll be able to use it about 95% of the time. So it's a good bet. Just in case you want to give it a shot, I would write something like sum divided by 4 equals question mark. And then I would label that as last 4 days. So what I've done is just read, I've written some half math, half English, and then that's made it a little bit easier for me to create good equations, label those equations so I don't get confused later, and have a little bit easier time putting these potentially disparate pieces of information together. And again, I'm just trying to harp on the points that I see people struggle with the most. Maybe you're not struggling with word problems at all. If that's you, that's amazing. Most people are not like that. The vast, vast majority of folks who I talk to every year are having major, major problems with their word problems approach. And a lot of times the fixes are super simple, like almost comically simple. And that's why we invented this sort of like multiple level approach to teaching these questions. Because I think once you see it work on the harder questions, I think you're a little more motivated to practice it on the easy level questions. And we'll bring that full circle a little bit later in the lesson. So at this point, once I have all that mapped down in front of me, I can step back a bit and see what the best move is likely to be. I can see that I can solve for the sum of all 10 days, and I can also see that I can solve for the sum of the first 6 days. It looks like if I can get those two values, I can then figure out what the sum is for the last 4 days and figure out the average of the last 4 days from there. So let's go ahead and see if that works. I'll solve sum divided by 10 equals 400 by multiplying both sides of the equation by 10. And that will give me sum equals 400 times 10, which of course equals 4,000. So for all 10 days, $4,000 is the total revenue. Side note, if you're just starting out, we've got a math basics series on all the essentials that it may have been a while since you've used, including like solving equations. So please check that out if that sounds helpful, and feel free to return here when you're ready. Those math basics episodes are going to be linked for you in the description. I've also got a similar equation for the first 6 days. So I'm going to take sum divided by 6 equals 360, and then I'm going to multiply both sides of that by 6. And that gets me sum equals 360 times 6. I'd probably do some long multiplication there. We've got a math basics episode on how to reskill with long multiplication as well, if that'd be helpful. And I'm recommending that because I'm going to gloss over the details of long multiplication because I've done a lot of math on the pod so far. And if you want to hear me do math on the pod, then the math basics episode has got plenty of that. But suffice to say, if we did the math there properly on 360 times 6, we would get 2,160. So now we know the revenue for all 10 days and the revenue for the first 6 days as well. If we find the difference between those two, that should get us the total revenue for the last 4 days. So let's compute that. Let's go ahead and subtract 2,160 from 4,000 to find that difference. We've also got a long subtraction episode linked below. And if we perform our calculations correctly, we should get 1,840. And that represents total revenue for the last 4 days. That's great news, because if we divide that by 4, we should get the average for those 4 days. And that's what the question's asking us to do. So if we do our math there properly, and we've got a long division math basics episode there for you also, we should get 1,840 divided by 4 is equal to 460. And that should lead us to our correct answer, which is option D, as in delta. So I was a little surprised by the wrong answer distribution in this question, because I thought some of the wrong answers would be more popular, because I thought people might make some computation mistakes on this question. But I actually don't think that's happening, which is kind of interesting. And we'll see that on a later problem as well. It looks like people are really performing the math well in these kinds of situations. Still, a decent number of us miss these questions. And this one in particular, I don't think it's an overwhelming number of us, but I think it's like 8%. 8% of us get this one wrong. And, if you step back and think about the math, sure, it might have been a long time since you thought about averages in terms of an equation. It might have been a while since you've done some algebra. It might have been a while since you've done some long subtraction. But if you've been studying for a while, that one should be gettable for you. And yet, clearly, it's not gettable for a lot of us. And I really struggled with these as well, even when I had been studying for a while. And again, I think it comes back to the organizational piece. That's what I've seen time and time again. hopefully this question was a breeze for you. Hopefully there were no organizational challenges here, but if there were, and I'm guessing there were for at least a handful of you, let's really focus our energy on that, since that seems to be the main bottleneck here. The incorrect options seem to be equally popular, and I think that suggests that the best things that you can do are implementing good organization. So there isn't like a key trap answer where a lot of the wrong answers are going. It's fairly evenly distributed. And I think that means people are just getting confused and then guessing, or they're just getting it right. Like 92% of us get it right. So that's good news. And the more I think about it and the more I help people try to overcome some of those challenges, the more the half math, half English thing is the thing that I think works in the widest variety of situations. So, sure, if you and I were working one on one, I might be able to give you some more detailed and specific advice about exactly what the best way for you personally to approach these questions is. But given that we're in a more generalized public format here, the half math, half English thing should get you where you want to go. Without very much downside at all. And that's true even if you're operating at a super, super high level. I work with people who score in the 99th percentile pretty regularly, and even they really struggle with word problems. Maybe not this exact one, but harder versions of it. And the half math, half English thing just does really, really well for those folks as well, and everybody in between. So if you haven't been implementing that, I would give that a shot. If you're already having tons of success on questions like this, then perhaps obviously like keep doing what you're doing. Now, final point here is you definitely do want to practice your computation basics, because I also think one of the reasons that the wrong answers are kind of spread out is people might not be making computation mistakes, but they're just getting bottlenecked on the computation and then guessing on the problem because it's like taking too long, or they're getting stuck or getting frustrated. So that's a very solvable thing in your preparation. And you don't need tons of hours of practice on those computation materials. I think those math basics lessons I just mentioned, plus maybe 10 practice questions each, is probably going to be more than enough for all of you. But if you need 50, go ahead and do 50. If either of those two things get mixed up here, meaning mixing up the translation or mixing up the computation, things can go pretty badly. But I think the good news is that if you have good systems of organization, you're very, very likely to be successful. And that's true of like basically all word problems. So if there are any notes to self that you want to make here, I would recommend pausing and making those, either text or email yourself if you're on the go, to make a note for later when you're back at the desk. Or if you're at a desk and you're practicing, I recommend making a note or maybe a flashcard for anything you want to remember from that, so that future problems go smoothly for you. Again, recommend pausing to make that, because we're going to jump right into a slightly more challenging question right now. Problem number 2 says the distributor of cases of a certain beverage charges $60 per case for orders of 1 to 5 cases, $50 per case for orders of 6 to 20 cases, and $45 per case for orders of more than 20 cases. If the distributor filled 3 orders, one for 3 cases of the beverage, one for 11 cases of the beverage, and one for 30 cases of the beverage, what was the total amount the distributor charged for the orders? I'll read that again. The distributor of cases of a certain beverage charges $60 per case for orders of 1 to 5 cases, $50 per case for orders of 6 to 20 cases, and $45 per case for orders of more than 20 cases. If the distributor filled 3 orders, one for 3 cases of the beverage, one for 11 cases of the beverage, and one for 30 cases, 30 cases of the beverage, what was the total amount the distributor charged for the orders? Option A is 1,960, 1960. Option B is 2,000. Option C is 2,040, 2040. Option D is 2,080, 2080. And option E is 2,280, 2280. As always, recommend pausing. And I'm just going to jump right in. Really good follow-up to the previous problem because, once again, we're in a situation where success is going to depend heavily on our ability to translate, organize, and compute. But also, again, if we do a good job on those things, we should do really well. So let's talk through what a solid approach might look like, and we're going to borrow heavily from the previous problem to hopefully show you how to use some of the principles we talked through in that question as well here, and how they apply across the difficulty spectrum. First, again, let's write what's given and asked using some half math, half English. So I'd probably write something like 1 to 5 cases equals $60. And then 6 to 20 cases equals $50. And then 20 plus cases equals $45. So just capturing what's given there. And then I'd write something like 3 cases plus 11 cases plus 30 cases equals total charge ? And if you struggle to lose track of the question, maybe putting a box around that or circle around that could be a good idea. We were talking about that on some of the problems we spoke through last time. From there, we should hopefully just have to compute to get our answer, because it looks like we just calculate the individual cost of each order and then we add those up, and then that's going to yield the total that we want. So let's go ahead and do that math. 3 cases is going to be 3 times $60 each for a total of $180. 11 cases is going to be 11 times $50 each for a total of $550. And 20 cases will be 30 times $45 each for a total of $1,350, 1350. Again, if you want help reskilling with long multiplication, please check out the Math Basics episode series below. Personally, I would for sure use long multiplication here, even though I could probably do that math in my head, simply because it's less error prone when I write it out physically. And odds are most of you are going to be in that boat. If you're really, really amazing at doing math in your head, then by all means keep doing what you're doing. But I really think the whole mental math thing is way over recommended. People are like, oh, speed. Speed doesn't really help me if I'm missing questions I know how to do. There's a balance there. Yes, obviously I want speed, but I don't want to be fast and bad. Okay, we were going deep on that last week as well. Same thing here. It's really easy to rush your word problem setup, make a mistake, and then do a bunch of correct math on that thing, or try to speed through the math and miss a lot of questions you know how to do. And because the GMAT's an adaptive exam, if you miss questions you know how to do, the algorithm's really going to punish you for that. And we really, really don't want that. So they really reward not making those kinds of mistakes on questions you know how to do. And they actually are pretty easy on you with the scoring algorithm. If you miss questions that are really tough, that are like a difficult conceptual thing, but you execute well, like usually you're not going to get punished for that in the scoring algorithm, which is kind of interesting. It's different from typical exams that are purely based on accuracy, number right, number wrong. The GMAT's not strictly based on accuracy. We've got a video going deep on that on our website. So feel free to check that out. That's the gmatstrategy.com, and I'll refer back to that at the end of the episode. But if you want to pause here and go along on that scoring algorithm piece, if you're curious, highly recommend that, as there is a just overwhelming amount of disinformation about how the scoring algorithm works online. My mind is blown every time I try to search it or get a AI to explain it to me. Man, it's really tough as a student coming into this process. So we're doing our best to try to clear that up for you there. So let us know if you have feedback, and feel free to reach out to us if you have questions about any of that stuff. Okay. Let's presume that we did the math properly there. And if you're me, I've done some long multiplication on all of those just to make sure I didn't make any mistakes. And now we're just going to add those up to get the total for all the orders. So 180 plus 550, that's 730. I'd probably do some long addition there. And then 730 plus 1,350 is going to be 2,080, 2080. We've also got a long addition episode from the Math Basics series linked below if needed. And that's going to get us to our correct answer of option D, as in delta. When I was first preparing this lesson, I thought for sure the previous question we did was going to have a higher difficulty rating than this one. But I was totally wrong about that, which was really, really interesting. Actually, twice as many of us missed this question versus the previous one, which was a big surprise for me because I think this one seems a lot simpler to put together. There's fewer steps, like the equations are a little simpler. It's just addition and multiplication rather than the average things sometimes can throw people for a loop. And like people get confused about which average is which on the previous problem. Yeah. So anyway, I did some digging into this, and most of the incorrect answers center around one option in this particular question, which is option E, as in echo. And thought about that. That's the answer you would get if you slightly misinterpret what the question is telling you. And instead of thinking of the pricing structure as siloed the way that we did, it appears a lot of us think of it as a tiered system, meaning for the first 5 cases you order, it's $60 each, and then after that you pay less for the additional items in the order. So for example, if I ordered 20 cases, it wouldn't just be 20 times $50 in that tiered system. It would be $60 for the first 5 cases and then $50 for the next 15 cases. And that's actually a much more computationally intense way of interpreting the problem. But what I thought was really interesting, kind of relevant to the previous question also, is pretty much all of us either go for D or E. And there's very few of us picking the other options. There's a few handful of us. And what I think that suggests is very few people are making computation mistakes. And instead, they are interpreting the problem incorrectly from the beginning and then doing lots and lots of correct math on the incorrect interpretation. So again, that's why you're going to hear me push these simple translating and organizational techniques so much, especially if you go back in time and listen to some of the earlier episodes that we've done on word problems. And by the way, we've tried to make these episodes easy to search. So if you search for a particular topic like word problems or statistics or averages, you should find multiple episodes where we discuss those things, unless we haven't done any episodes on those topics yet, in which case we'll get to them. But this misinterpreting of word problems is just a massive thing. So most of us usually get good enough at the computational side at some point. You might not start there. But the execution, setup, and strategy side is just as important. Since if I do all the right math on the wrong setup, obviously I'm going to miss questions I know how to do, and I'm going to get really punished in the scoring system for that. So that's just really different than how a lot of us learned how to do math in school, where there's usually partial credit. It definitely can be a big adjustment here because there's no partial credit on these questions. It's like I either pick the right answer or I'm 100% wrong, no matter how close I got. But I think a good way to think about that is just like that the standards of execution on the GMAT are a bit higher than those in regular school. And that should hopefully give you the motivation to invest in good execution habits, and also the comfort that like when you do eventually earn a high score, like that's going to be meaningful to business schools and the classmates that you'll eventually have. You can trust, these people can execute things well. I think that's valuable, especially in high pressure environments. And most of us don't start good at that. Most of us don't come out of the womb really good at executing in high pressure situations, but we can build those skills. And if you're already crushing the GMAT, then it's kind of like, why are you here right now? But if you're struggling with the GMAT, it's a great thing that you're here right now. And it's a great opportunity to start building those better execution skills, which are definitely transferable. How transferable is long addition? Probably not going to use that in the rest of your career after you're done with the GMAT, but executing with high attention to detail under extreme time pressure and stress, super valuable, super valuable. So if that helps, bottle that mindset, and if not, we'll move on. I really hate to sound like a broken record, but for most of us, all it's going to take to fix the interpretation pieces is that half math, half English step that I was talking about earlier. A lot of people really resist that, again, because they feel like they don't have time for it. But again, we already talked about how it's just a trade. It's a risk reward trade-off. Yes, I might add 20 seconds at the beginning of the problem, but if I save myself a minute of double checking at the end of the problem because I get an answer that's not in the answer choice, and then I have to reread, find my mistake, and then redo all the math, that's a much, much bigger problem. So it's kind of like the lesser of two evils. Obviously, it'd be great if I could get all word problems right in 5 seconds without having to do any additional work. That would be amazing. But given that that's not going to happen for most of us, the next best thing is just good, simple, repeatable process that you can iterate on and customize and make perfect for you over time. Again, really interesting how few computation misses there are in this particular question. So really seemed like everything centered around understanding, interpretation, and organization here. Once again, if there's any notes to self to make there, maybe there was a computation mistake. Maybe you want to, maybe I finally sold you on the half math, half English thing after the first problem. That could be a good takeaway. Or maybe it's time to spend some time on some long multiplication, long addition. Just smoothing that out a little bit. Maybe that was a hiccup for you. If there are any notes to self, I recommend pausing, send those to yourself, text or email yourself, or put them into a digital flashcard on your phone if you have that capability, if you're on the go. Otherwise, we'll wrap up with one final, slightly more challenging question here. Problem number 3 says, in a class of 30 students, 2 students did not borrow any books from the library. 12 students each borrowed 1 book. 10 students each borrowed 2 books. And the rest borrowed at least 3 books. If the average number of books per student was 2, what is the maximum number of books any single student could have borrowed? I'll read that again. In a class of 30 students, 2 students did not borrow any books from the library. 12 students borrowed 1 book. 10 students each borrowed 2 books. And the rest borrowed at least 3 books. If the average number of books per student was 2, what is the maximum number of books any single student could have borrowed? Option A is 3. Option B is 5. Option C is 8. Option D is 13. And option E is 15. As always, I recommend pausing. Try to get as far as you can on your own. Much more challenging question by the numbers here, with about 3 times as many of us missing this one as the first one, and almost twice as many of us missing it versus the previous one. So it's a good follow-up for both those problems because it really blends the same concepts of good setup and good execution. And then it just takes the organizational and computational complexity up like 4 or 5 notches. Like there's just a lot more steps built on top of those basic frameworks. But again, good news is if you execute well on the basics, you've got a great shot at getting long word problems right under time pressure. And that's our objective. Once again, let's work on making those easier for you to implement. We'll start by writing what's given and what's asked in an organized way. So we've got 30 total students. I'd probably just note that in some kind of simple way. Something like 30 students, something as simple as that. Then we're told that 2 students borrowed 0 books, and this could be a good opportunity for some rows and columns. We've talked about that a lot on previous word problems and word translations episodes. So if you want a little bit more detailed instruction on how to recognize when it's good to use those and how to implement them well, then highly recommend searching that in the feed and checking those episodes out. I'd probably here label one column as students or number, and then the other column as like book number or borrowed books, something like that, whatever makes sense. And so I'd put a 2 under students and then a 0 under borrowed for that first data point, since those first 2 students didn't borrow any books. Then we're told 12 students borrowed one book each. So I would note a 12 under the students column and then a 12 under the borrowed column. 10 students borrowed two books each. So I'd write a 10 under the students column and a 20 under the borrowed column. And then we've got some unknowns. We are probably going to have to solve for the remaining students and also the remaining books borrowed. So I'm just going to write some question marks in each column at the bottom there to remind me to circle back on those quantities. But what I think you'll find is a good habit to get into is capture all the given information and the question before you start solving for anything. I know that might just really, really go against the grain for a lot of you. It can be really scary to do that, but it usually leads to just much, much better net results. Very similar to what I talked about earlier of like, if I'm so panicked and rushed thinking I have to start doing math or I'm like, never gonna get where I want to go, then it's going to be really, really hard to get things organized well. And the math I'm going to do is highly likely to lead me down the wrong path. So let's capture all the given information before we do any computation. We are told the average number of books per student is 2. So that's a good place to use some half math, half English. I'd write something like average per student equals 2. And then we finally get our question, which I'd probably just notate as like max books single question mark. So we're trying to maximize the number of books that one single student could have borrowed. Okay, what having all that notated allows us to do is step back a little bit to the bigger picture and start to find the best opportunities to make progress, because you might see there's a few different places I could compute things that could be helpful. But I would like to have some order to the chaos if I can. If I can't find any obvious place to jump in, that's the place to just jump in and start doing something. But the ideal situation is to step back and say, okay, if I solve for this, I can get this, and then that'll lead me where I want to go. That's a really, really good position to be in. So here, we're still missing the number of students who borrowed more than 3 books. So let's start with that. Because if I can figure that out, then I can figure out how many books that group of people borrowed. And if I can figure that out, then I can maximize the number of books that one of them borrowed. So let's start with that. We know there's 30 students. 2 borrow 0 books, so that's 28 students who did borrow. 12 borrow 1, so that means 30 minus 2 is how I got 28 there. 30 total students, 2 borrow 0, so now we have 28. 12 borrow 1, so we take away 12 from the 28 students. That means 16 borrow more than 1. And 10 borrow 2. So that leaves us with 6 who borrow 3 or more. And so I would write that at the bottom of the students column, like 6 equals 3 plus or something like that. Now we need to figure out the total number of books that were borrowed. Because if there's no limit on that, then the answer to the question would be like infinity would be the maximum. There'd be no upper limit on the number of books a student can borrow. So if you think about, okay, where could we find that total? That's where an average equation could become really, really helpful. In fact, it's a good time to step back and talk about a good general principle if you are getting stuck in the middle of word problems, which is, it works on all quant questions, actually. It's a good idea to step back if you're stuck and ask, what given information have I not used yet? It's really valuable for a few reasons, but one of the reasons is quant questions rarely provide information you don't need. So if they're giving it to you, you probably need it. It's part of the reason why writing what's given so clearly is important. It allows you to quickly take stock of what you have available if you get stuck, and it also makes all the information that you need to solve the problem more available. So I've coached a lot of people through problems like this, and you may not have been able to make the connection in this problem that the average lets you solve for that total number of books. It's a common place to get stuck. But that's actually not super important today because we're not here to get these problems right necessarily. We're here to improve and get future problems that are similar to this one right. So the problems we're doing today are just tools to help you with future similar problems. So don't stress if you couldn't make that connection today. But couple things that you can use for the future. Number one, if you're stuck, figure out what given information you haven't used yet. Second, averages can be used to figure out total quantities of things. That's a helpful takeaway if you didn't see that the first time around. And then like we've talked about so much, writing what's given clearly can help make it easier to solve word problems. Okay, so let's get back to the solving. So we know that 30 people borrowed an average of 2 books each. So I'm going to write the average formula as sum over 30 equals 2. I'm going to multiply both sides by 30 to get that the sum is 60. So that means a total of 60 books were borrowed. That's going to allow us to figure out how many total books the 6 people who borrowed more than 2 books borrowed. And that should help us answer our question. So let's go back to our rows and columns here. 60 books total. 12 people borrowed 1 book each, so let's subtract those 12 books to get 48 books remaining. 10 people borrow 2 books each, so that means 20 books go to those folks. That leaves us 28 books not accounted for yet. And so those 6 people who borrowed at least 3 books borrowed 28 books in total. That's good to know because we can rule out the infinite book borrowing possibility that I brought up before, and we should be able to compute what we need. So if we want to maximize the number of books that one person borrows, that's the same as minimizing what the other people borrow. So if we isolate our one maximizer and we just minimize the other 5 of those 6 people remaining who borrowed 3 or more, we can minimize the 5 by having them borrow exactly 3 books each. If those 5 people borrowed exactly 3 books each, they would have borrowed a total of 15 books. If we subtract those 15 books from the 28 books borrowed by those 6 people, we would get that 13 books is the maximum that the 6th person could have borrowed. And that leads us to our correct answer, which is option D, as in delta. Okay, so clearly much more complicated than the previous questions, again, as the result of just more steps. But interesting is that it's also more organizationally complex, partially just because it provides way more information. So a few things that I find interesting versus the previous 2 problems. First, a lot more people get this question wrong. That's not super surprising because there's more steps to do, meaning more opportunities to get stuck or make a mistake. But second, the core skills here are exactly the same. It's good organization, making sure you're clear on what's asked, using the average formula well, and avoiding computation mistakes. And there's just that just becomes more important on a more complex problem, but it's still the same core approach. So what does that mean for your study time and for your success? It means that you want to develop good habits on easy problems. This can be difficult for a few reasons. One reason is we often feel rushed during our prep time because we want to get to the harder problems. We want to get the process done quickly. That's super understandable. But what I hope you'll take away from today's discussion is that one way you can accelerate your progress on the exam and with your studies is doing a more thorough job on your easy level problems. If you build those good habits on the easy level problems, you're going to be way, way faster on the harder questions. You're going to miss way fewer questions you know how to do, and your score is going to actually represent all that time and energy that you invested in studying. And these were all huge mistakes I made back in the day when I was in your shoes. I raced through a ton of content, just learned all the material, knowledge, no process, no strategy whatsoever. And my score went down. So you can imagine how that felt. Not good. And then slowly I went back and put all these pieces together that I'm helping you out with, hopefully, today. And that's when I started to really see the gains that I wanted to. So hopefully I'm saving you a lot of time here. Now, just to be super clear, some hard problems are just hard conceptually. And no matter how well you execute on them, if you're not familiar with the concept, they're going to be hard. But those are actually the minority of hard questions in my experience. The majority of hard questions utilize the same principles as easier questions, just more of those principles. So I'm really, really hopeful today is going to be really helpful for you. As always, recommend pausing and making any notes to self about that question that might be helpful for you in the future, and possibly reflecting on the overall episode. And we'll pause and wrap up in just a moment. If you have any questions about anything we've covered today, please reach out to us anytime. We're at the GMAT Strategy on current social channels, or you can email us at contact@thegmatstrategy.com, CONTACT. As always, my greatest hope is this material is going to make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free presentation on how you can reach your dream GMAT score way, way faster. In the meantime, this is a regular show, so if you're finding value in it, please subscribe. And at the very least, please stay positive and please stay consistent with your studies, everybody. Business leadership needs your skills. Talk to you all soon.